In continuation of what we have seen in the last class regarding polymers and biomolecules, let us consider some of these questions in the form of some problems also. Now, problem number 1, this question is based on the polymer chemistry. A monomer A is considered. Probably you remember in polymer chemistry, polymerization leads to the formation of polyolefins, polydienes, and so on. Now, this monomer A undergoes ozonolysis reaction. Of course, when we mention the name ozonolysis, immediately it should strike that monomer A should contain double bond. Now, the products of ozonolysis are 2 molecules of formaldehyde and 1 molecule of this particular compound. 2 molecules of formaldehyde and 1 molecule of this particular compound. All right. Now, this monomer forms a polymer B. What are A and B? So, this question in one way is simplified in this fashion. A large number of monomer A undergo polymerization to form B. In order to find out this monomer A, the products of ozonolysis you have to consider. Now, let us write the products. 2 molecules of formaldehyde, HCHO plus I write this product OCCl C, I write like this. I bring the 2 double bonds like this in the linear fashion. A second molecule HCHO. Now, from the products of ozonolysis, it is possible for us to arrive at the nature of the original compound. Here it is A. It is quite simple to arrive at the original compound from the products of ozonolysis. Simply you remove these 2 oxygens. Similarly, here also remove these 2 oxygens and write the compound resulting from this. I can write this as CH2, put a double bond, CCl, CH, double bond, CH2. This should be the original monomer A. CH2, double bond, CCl, CH, double bond, CH2. Now, I think you know this compound, derivative of butadiene. This is 2-chloro-1,3-butadiene. 2-chloro-1,3-butadiene, and this is known as chloroprene. This derivative of butadiene is known as chloroprene. So the monomer A is chloroprene, and this undergoes polymerization, that is CH2 CCl double bond CH CH2, and N molecules of chloroprene will undergo polymerization reaction to give this polymer B. So, A monomer is chloroprene, from which, from polymerization reaction, I get this polymer B, which is known as neoprene. So, in the previous session, we have already seen chloroprene, the monomer, undergoes polymerization reaction to form neoprene. So, the answer is monomer A is chloroprene, and this undergoes polymerization to give the polymer B, which is known as neoprene. So, A, the monomer, is chloroprene, from which we get B, the polymer, which is known as neoprene. So, this particular question involves one of the important reactions of unsaturated compound, that is compound containing multiple bonds, and here a double bond. Question number 2, it is a simple question. This reactant RCHNH2COOH, it is quite obvious. This is an example of an amino acid, that is a compound containing both carboxylic acid and amino group. This is treated with HNO2. HNO2 is nitrous acid. HNO2 is nitrous acid, and this reaction is a characteristic reaction of amino group. It is a characteristic reaction of amino group. Now, this reaction involves the formation of the product A. What is A? That is the question. Now, whenever a molecule like this containing an amino group is treated with nitrous acid, the reaction which is taking place here and which you should remember is NH2 group is replaced by OH group. NH2 group is replaced by OH group. So, from this amino acid, by treating it with nitrous acid, we get a hydroxy acid. From amino acid, we get the hydroxy acid. So, if you look at the 4 options, first one is formation of carboxylic acid. Second one, it is given as NH2 replaced by NO2. That is not taking place. C is the correct option. So, an amino compound, when treated with nitrous acid, forms the corresponding hydroxy compound. So, amino acid leading to the formation of a hydroxy acid when the amino acid is treated with nitrous acid. So, this reaction won't lead to the formation of an alkane or a nitro carboxylic acid or a simple monocarboxylic acid. So, C is the correct option.